this video, we will learn about how to find relative extremum by using first derivative test. In previous lesson, you already learned on how to find critical point. So, in this lesson, we will find the connection between critical point and relative extremum. So, critical point basically can be classified into three cases, which are maximum point, minimum point, and inflection point. And basically, they also will use the term nature of critical point in order to identify these three types of point. Extremum point, also known as relative extrema or local extrema. So, in order to find relative extremum, we have 5 main steps. Step number 1, we have to find critical number. Step number 2, we will arrange the critical number correctly in the correct interval. After that, we will determine the nature by using the table below, and this table is basically our first derivative test. After that, we will find the critical points, means that the coordinate of our critical point, and last part, we will make a conclusion. Let's proceed with example 3. Determine the nature of y equal to exponent to the power of x squared. When it comes to nature, means that we have to identify whether our function have a maximum point or minimum point. So, based on our 5 main steps, step number 1, we have to differentiate our y equation. And in this case, since we have exponential function, I just recap back basic formula in order to differentiate this equation. So basically, we just have to copy it back. After that, state the derivative of your power and ln with your base, but bear in mind ln e would be equal to 1. So, the y dx of this equation would be 2x exponent to the power of x squared. Now, we will identify the critical number. In order to do so, we have to let our dy dx equal to 0. So, if we equate 2x exponent to the power of x squared equal to 0, we will get x equal to 0 as our result. Now, proceed with the third step. We have to construct a table consists of 4 rows to determine the nature of our points. So, our first row will consider the interval. Number of interval is based on number of x that we have. If we have one value of x, means that we will have 2 intervals. Now, proceed to second row. Second row would be value of x. Our third row is basically sign of our dy dx, and last row consider as slope or our conclusion. Now, we will fill up our table. So, start with the first row, interval. Interval means based on the value of our x. If our x equal to 0, means our interval will stop at 0. So, from here, 0 will be in the middle. So, our first interval will be from negative infinity up to 0, while our second interval will be from 0 up to positive infinity. Settle with the first part. Now moving on, for second row, our value of x is basically you just have to choose any value of x that represent that interval. For example, if we have from negative infinity up to 0, I will choose one value. In this case, I choose negative 10. And for next interval from 0 up to infinity, I'll choose the value of 10. You can choose any other value because the result will be the same. Proceed with the third step, sin dy dx. Based on the value that you have choose from our second row, you just have to substitute this into your dy dx. You just have to use your calculator for this part. So if negative 10, I substitute into 2x e to the power of x squared, I will get a negative result. And if I substitute 10 into 2x e to the power of x squared, we will get positive result. You don't have to state the value because we only want to find the sign. Now, last part for slope or our conclusion. If we have a negative sign, means that our slope is decreasing. And if we have a positive sign, means that our slope is increasing. It's sort of we go down the hill and going upward back. Okay, settle for the third step. Now moving on for the fourth step, we have to find the coordinate. So in other words, we have to find value of y. When our x equal to 0, we just have to substitute this into y equation. So we will get the value of 1. So here the coordinate would be 0, 1. So coordinate 0, 1 based on this slope means we put it in the middle. From here we know that this is basically a minimum point. So finally our final step, the conclusion, we can state that basically 0, 1 is minimum point. Proceed with example 4. So, given a function y equal to 3 over x minus 1 plus x over 3, we have to find our dy dx, hence determine the local extrema by using first derivative test. So, first part we have to find dy dx. This is basically a basic equation. You can directly use a basic rule to settle this down. So from here our dy dx or y prime will be equal to derivative of 3 over x plus 1. You can change this into 3 times with x minus 1 to the power of negative 1. After that you just have to use power rule. That's why we get negative 3 over x minus 1 squared. Derivative of x over 3 is basically 1 over 3, and this will be our dy dx. Hence, we have to determine the local extrema. So now we are back to the 5 main steps. Step number 1, we have to find the critical number, means that we have to equate our dy dx equal to 0. So if I equate our equation to 0 and simplify the equation, we will get that x will be equal to 4 and x will be equal to negative 2. These are basically the first case that need to be considered in order to find critical number. Proceed with the second case. Second case, in order to find critical number, would be when you consider your dy dx as undefined. So, if we equate our denominator equal to 0, we will get x equal to 1. But if we check back, once we substitute x equal to 1 into y equation, we will get an undefined value of y. Means that this coordinate does not exist, so we reject this value. From here, we can conclude that our critical points consist of two values only, which are 4 and negative 2. Now, we will proceed with the third step where we have to construct the table for first derivative test. So, our first row would be our interval. So, for interval, since we have the value of negative 2 and 4, means that our first interval would be from negative infinity up to negative 2. After that, our second interval would be from negative 2 up to 4. And our last interval would be from 4 up to positive infinity. After that, you just have to choose one value of x that represent each interval. So, for our first interval, from negative infinity up to negative 2, I choose the value of negative 10. For the second one, I choose 0. And for our last interval, I choose 10. Next, we just have to substitute the value that you have choose into your dy dx equation. Bear in mind, you don't have to show these steps. You can directly use your calculator. So if I substitute negative 10 into our dy dx, I will get positive result. If we substitute 0, we will get negative result. And if we substitute 10, we will get positive result. After that, we can make a conclusion or our slope. If it's positive, means our slope is increasing. If it's negative, means it's decreasing. So from here, we can decide that this basically, we will have 1 point at the top and 1 point at the bottom. Now,
we have to consider the coordinate of our critical number. So when our x is equal to -2, just now substitute -2 into our y equation, we will get the coordinate of y as -5/3. Next, when we substitute the value of x equal to 4 into our y equation, we will get y equal to 7/3. For x equal to -2, we can see from our table it is at the top, means the coordinate of -2 and -5/3 will consider as a maximum point. And based on the table, once again, value of x equal to 4 is at the bottom of our slope, means that the coordinate of 4 and 7/3 will be our minimum point. And that is basically how you determine the relative extremum or local extremum by using first derivative test.